Okay, let's take a look at some of the important concepts of Chapter 11, Section 1. Let's start with the idea of vector. Vector is defined as magnitude, or we can think of size, and a direction. This is similar to scalar, which is actually not mentioned in your textbook, but is used in other courses of physics. And it's important to know that scalar is almost the same as vector, but it does not give us this important direction. That means a scalar would be simply stating something like 4 meters, whereas a vector would say 4 meters to the left. Okay, with that understood, we can move on to the idea of displacement. Displacement really is the idea of distance, often measured with meters or kilometers, along a straight line. This has a starting point and an ending point. The book gives us the following example. If this car A, begins at 0 and travels 4 kilometers first, pauses, and then travels an additional 4 kilometers, 4 plus 2 equals 6 kilometers. So that means the total displacement along a straight line is 6 kilometers. This seems easy enough to understand. However, let's look at example B. In example B, we see that this car travels a total of 4 kilometers to the right, stops, and turns around to travel 2 kilometers in the opposite direction. This means it travels a total of 4 kilometers, stops, and turns in the other direction 2 kilometers. That means rather than a plus, we must put a minus. That means that while the total displacement in A is 6, the total displacement in B is only 2 kilometers. This may seem confusing because the total distance traveled by car A is 6 kilometers. Also, the total distance traveled by car B is 6 kilometers, 4 kilometers to the right, 2 kilometers to the left. But distance is not always the same as displacement. Here, a small correction needs to be made to the textbook. The textbook says that we start with the starting position and then we figure out our final position. In reality, that is not how you find displacement. The correct formula for displacement is that you begin with the final position and subtract the initial position. Although this formula may seem complicated, it's much easier when you understand that this symbol delta just means change of direction, or in this case, change of displacement. So the correct formula for displacement is actually a change of displacement is measured with finding your final position and then subtracting your initial position. Whereas your textbook says that the formula should be 4 plus 2 equals 6, in reality, our final position is 6, and we should subtract our initial position. Now, it's important to notice that in this case, the answer is the same. 6 minus 0 is still 6. With picture B, we notice another change that should be made to our textbooks. Again, the final position is where we start. And so our final position is actually what? 2 kilometers. Then we subtract our initial position, which is actually, again, 0. So 2 minus 0 equals 2. Notice the answer, again, is the same answer. However, it's important to notice this difference, especially when you get into more complicated physics. Let's look at an example of a somewhat more complicated question. In this question, the starting position is not 0, but 1.5. We are saying that the teacher starts 1.5 meters from the wall and walks to a final distance of 3.5. Again, we start with our final position, 3.5, and we subtract our initial position, 1.5, to find our total displacement, which is positive 2 meters. It's important to notice that when you get into more complicated physics, the left, if the teacher or the object is moving to the left, this will be negative. Now let's look at a little bit more complicated of a question. What if our final point and our initial point, the movement is not along a straight line as indicated by this red line, but actually our person travels 1 block to the east, 1 block to the north, 2 blocks to the east, 3 blocks to the north. Well, their overall distance would be 3 plus 2 plus 1 plus 1 for a total of 7 blocks of distance, total distance. The actual displacement is much different. Remember, displacement just measures the distance from final to initial. In order to find that along this particular question, we will need this formula. In this formula, A is represented by the distance from along this part of our triangle, B is represented by this section of our triangle, and C is represented by this portion, our slope of our triangle. That means that A, or 3, 1 plus 2, 3 squared, plus B, or 3 plus 1, 4 squared, is equal to C squared. That means when we do this math, we get 3 squared, or 9, plus 4 squared, or 16, equals C squared. When we add 9 plus 16, we get 25 equals C squared. However, in order to get rid of our C squared, we must take the square root of both sides. That will give us the square root of 25 is 5 equals C. We see this reflected here.